Swayam Prabha. Digital India. Educated India.
So where is A5 matched? Yeah, so A5 is not there. Sorry, A5 is, because there is nobody who is matched to P5, right? So actually that cannot happen, right? An applicant cannot remain unmatched with respect to a popular matching. So A5 is not there in the, I mean, yeah, if there are 10, if I have drawn 11 posts, there are only 10 applicants, but I should have numbered them better so that this is P0 and there is no applicant A0. Right? So she observes the following, that very conveniently I have said AI is matched to PI, but for P5 there is no applicant that is matched to it, right? Otherwise I should have drawn an edge outside that. It could be matched to its dummy last resort. Remember, these P's need not be true posts. Everybody got it? Is this fine? So what this tells us is that we can very conveniently determine whether an applicant belongs to this set AF, AS or AFS using this structure, which is the switching graph structure, right? And this is in general a very useful thing to know about, irrespective of what we are developing it for, and you can think about switching structures for different problems that you are interested in. So good, yeah. Perfect, you can apply a path on M dash, right? Now you have another matching which is M dash. Now this is the switching graph. We don't know whether we came from, where did this M prime come from, right? So we again have the same structure on that, and we can apply paths starting at S pos. And does it matter? We are making lot of changes to our matching, that's all. It doesn't mean anything about the popularity. We are making lot of switches, that's all. Any other questions about the graph or the properties of that graph? Okay. Okay, so now once we have identified this indeed says we have also identified the underlined posts for every applicant, which are its popular pairs. So therefore these are analog, I mean these are just saying things in two different ways. So we have identified AF, AS and AFS applicants, right? You have a question? Yes. Actually posts are not AF or AS, but what is the question? They can be matched. So okay, so the edges that are in the cycle, they are corresponding to applicants of the original graph, right? So therefore those applicants can be, they can be matched to F post as well as their S post in some popular matchings of the instance, and therefore I am calling them AFS applicants. Yeah. In the tree structure, yes. So suppose you have, so let's take this. Okay, so the concrete statement is that an applicant, okay, so an edge is a popular pair, an edge is a popular pair if and only if it belongs to some switching path or switching cycle. What is a switching path? A switching path is a path in the switching graph which starts at an S pos and ends at a sync vertex, right? So therefore I am illustrating this. Is this a switching path? So T1, is it a switching path? So I'll just write it clearly. So okay, so let M be a popular matching in G, an edge AP is a popular pair if 1 AP belongs to M, because remember M is a popular matching, so that itself is a witness for AP being popular pair, or so I should write this or here. AP or sorry the edge So let's read this. So that an edge AP is a popular pair if there is a witness popular matching that matches it, which is M. So if it belongs to M, yes, it is a popular pair, right? There is some popular matching that matches it. Or the edge MA. What is MA? The matched partner of A and the directed edge to P, right? So this is some P prime, it's a matched partner of A. So this P prime to P edge belongs to a switching path or switching cycle. If it belongs to some switching path, you can switch along that to get another popular matching. If it belongs to a switching cycle, then you can switch along it to get a popular matching. Does this answer your question, or what is? Yeah, so what we have proved is, yeah, maybe you are right, that what we have proved is that if it belongs to a switching path, then we can get a popular matching. You would like to see whether these are the only ways you can get popular matchings, right? But I'll not go into that proof in the interest of time, but it can be very easily done, right? Yeah, any questions about this part? And what is a switching path? So a switching path is a path that starts at an S post and ends at a sink vertex, and a switching cycle is any cycle in this switching graph, right? Anything else that somebody would like to know? Okay, so so now let's get back. What were we interested in? Why did we do all of this? To know how an applicant can falsify the preferences, right? So if an applicant is an AF applicant, it doesn't care about falsifying, because it anyway gets its top choice in every popular matching. So it just submits its true preferences. It will always assume that everybody else submits true preferences, right? Okay, so what we will do is, we will compute a strategy for an AS agent, that is, it always gets matched to its S post, and I'll leave the FS agent as a reading exercise mostly. It is in the write-up that we have shared, everything is there, so you can actually read it. So where is that AS agent belonging? I mean, in this switching graph, where should it lie? Remember, it is an agent is or applicant is an edge in this switching graph. So there are cycle components, there are tree there are sync components, there are non-sync components. Where is that applicant residing? Sorry, cycle component. And does it belong to the cycle? No, right? If it belongs to the cycle, it is an FS agent or FS applicant, right? So it is in this part of the graph, right? Okay. So if it is an applicant who is assigned to, or it is an applicant when it submits its true preferences. So let's call it AS applicant. So A belonging to AS, and it is, let's call him A1, and whatever is its, so we will call them P1, P2 up to PT, and there is also PT plus 1 and so on. Now this is its S post. We will just use this notation S of A1, and this is its F post, F of A1. Okay. Now one thing is that once the applicant decides to modify the preferences, it wants to get better, right? It wants to get that every popular matching in the modified instance must match him to something better than its S of A, because currently it is always stuck with its S of A. So what are its possibilities? Sorry? Yeah, it would want to possibly move to a situation where it can always get F of A, right? So let's look at this picture. So let's say that, let's now label this. So if this is S, this is F, this is S, this is F, this is S. So let's think of this A8 applicant which is matched to its S post, right? So its F post is belonging to a cycle. Now can it happen that can it move from a situation where it is currently at an S only applicant, that is AS, and it moves to suddenly F only, that is it should always get matched to its F post. Now remember that other applicants will not change their preferences at all, but if the other applicants do not change their preferences and only this applicant changes its preferences, what all can change with respect to the instance? So the question is that this applicant has complete flexibility to change all its preferences, but it cannot touch anybody else's preferences. So nobody's F post will change for sure. Can it happen that somebody's S post may change? Somebody's S post can change, right? If he makes his preference list in some way, somebody's S post can change. How can somebody's S post change? Because if he takes some post which was originally an S post and makes it as his F post, yes, he can stop that post from being an S post, right, for anybody else, right? So in particular, let's go to this example. So currently P6 was the S post for A3, whether it was interested or not, that is not my question, or even P5 was an S post for A5 and it was actually getting matched. But if A1 changes its preference list and makes P5 as the only post that it is interested in, that its top post, then the S posts of people can change, and that can drastically change the whole instance, right? It can change the whole switching graph and so on. Now we will ask, is it in his interest to do such a thing, right? So that is, move some post and make it its own F post, which will change the S post for everybody. So where does such post lie in his preference list earlier? So this is a post which was possibly not even his candidate S post, or it is possibly his S post. Is he interested in getting matched to his S post? He is already getting matched to his S post by giving true preferences, right? So look at this picture, and he is interested in getting matched to posts which are P1 to PT, right? Most likely P1, but we are asking, can he actually modify preferences and cheat, or is there any reason for him to get a post which is somebody else's S post and bring it as a top choice? Where are such S posts lying in his preferences, if at all they are there? After his S post, right? So if he brings one of the posts and puts it as a top choice, then that will start becoming his F post, he will get that, but in his true preference list that is really a very bad post, even worse than his S post. Therefore, in the modified instance he will either get his falsified F post or his S post, which will be even worse than that. So there is nothing to gain for him by taking a post from here which could be a candidate S post for somebody else and putting it as a top choice. That holds for his own S post PT, because if he puts PT as his first choice, he will get matched to PT, but that is nothing better for him, right. So therefore, what we know is that there are instances where he can change his preferences so that the S posts of people change, but such instances are not the ones which he is interested in. So we will say that an instance H is better than G for the applicant A1 if he gets better ranked posts in H as compared to in G, and he gets them always in every popular matching, right. But all these posts are not interesting to him. So what he is interested in doing is keeping P1 to PT minus 1 as one of his F posts, because if he makes anybody else including PT to and PT plus 1 and below as his F post, then he has this risk of modifying everybody's S posts also or changing the S post, but that is not interesting to him. Therefore, we will now use this notation FH of A1, because FH of A1 may not be equal to FG of A1 in the original graph, the true preference list. So what do we know about FH of A1? In what set should it belong to? Where should the falsified first post come from? Can it come from, can it be PT, PT plus 1 and so on? No, because if he does that, he will get it and it is not interesting to him. So what should be the set from which he should choose his F post? P1 to PT minus 1, P1 to PT minus 1. But by the definition of these posts, what are these posts? These are already F posts for somebody. So if he selects this as his F post, there is no risk of changing anybody's S posts as well, right. So he cannot change anybody's F post because everybody has given their own preference list. He has the ability to change anybody's S post, but if he chooses post from P1 to PT minus 1 as his F post, then he will not touch or modify anybody's S post, right. This is good. So now if we know this, that is, if he is a rational agent and if he wants to cheat to benefit for himself, then this remaining graph is going to look like this, that is, everybody else will have their own F and S posts. So he can also cheat to make sure that there is no popular matching in the instance, but that is even worse for him, because the central authority will say that okay, I will not do anything, there is no popular matching, but that is even worse. So therefore he will always, the current instance does have a popular matching, he will also want to keep the property that it admits a popular matching. So therefore one can easily argue that if this is the agent A8, then this F post P8 is his true F post P8 is never attainable to it, not as an FS agent in the modified this thing, neither as an AF agent. He would like to go to becoming an AF agent in the modified preference list, that is the graph H, but one can easily argue that you cannot get your true F post ever, right. Because if you got your true F post, there is a set of agents which will be left, one of them which will be left unmatched, and then that instance cannot have a popular matching. And this is formally argued by what is defined as a tight pair for a set of applicants and set of posts. So we take some set of posts and show that there are some k posts and there are exactly k applicants who want amongst these posts as F and S, and if you add one more applicant to this to be asking for a post in this, then you will have more number of applicants than the number of posts. Therefore you cannot have a popular match, therefore you cannot have a matching that matches all applicants within these posts, which is, I mean, I am just doing a slightly hand wavy argument using this diagram, right. So if nobody else's F post and S post change, then there is one more person asking for this post, and within the cycle you cannot match. So this is clear, right? So now what should he look for? So his P1 is gone out of question. So he still has P2 to PT minus 1. So this is his area of interest, P2 to PT minus 1. Okay, I will just P1, this is not possible. P2, P3, PT minus 1. PT is possible, but it is not interesting. So this is FG of A1. This is SG of A1. Now these are possibilities for him. Okay. So what should he set as his, I mean, is it possible for him to get any of P2 to PT minus 1? So again, look at this picture. So if this is the agent, and there are other components also, note that there is not only a single component. So where do P2 and P2 to PT minus 1 lie? We do not know, but where can they lie? Sorry, they can lie in this component, they can lie outside this. Remember, this applicant belongs to a cycle component. So if it is an AS applicant, so this AS, this belongs to a cycle component of GM, the original graph. So let's ask, if your P2 lies somewhere in the cycle in your own component and it is some post, so this is F, this is S. So there is some F post, yeah, maybe there is some more picture here. So if your P2 lies, P2 to PT lies here, can you do much about that post? So what would you want that post to be? That post should be available for you, right? That post you would like to get matched to, but for that, that post should be available. Even if that post is not currently available because it is matched, because the only posts that are available are actually S posts, which are even worse than your own S posts, so those are not interesting to you. But there are some F posts which you are interested in, and they may not be readily available for you, but can you make them available? So let's think of this applicant being A8, and there is another component, and so I will draw the picture in this here where this is clear. So there is P1 which is in the cycle component. So this is P1, this is A1, it's currently matched to its PT, so this is S post, and there is a cycle component here that it must belong to a cycle component. So this is the picture, this is P1. Now let's say there is P2 here. Remember, P2 is an F post for somebody, so it is matched. So this is P2, this is a red post, and so this is S, this is F, and let's say this is all that is there. So this is a sink, right? So I will call this P3, P4, P5, right? So this is how the picture looks like in the whole graph. So now this is P2 which is of your interest. This is a red post. Just to recall, there are red posts which are F posts. You cannot leave them unmatched in a popular matching. P1 is a red post, therefore this is a red post and this is a red post, right? So this is the picture of the switching graph. Can you do anything about this? Okay, let's ask, can you make P2 free first? Can you get P2 free? Can you unmatch P2? Currently it is match, right? How can you unmatch P2? There is a path which is not a valid path, because if I switch along that, P2 remains unmatched, but there is a path to a sink vertex, right? So let's apply that path. If you apply that path, everybody else switches to its S post or F post. So they do remain in their F and S. We have already argued that F and S do not change, but P2 becomes unmatched, right? Is this clear? So if P2 was like this, P2 becomes unmatched, but it is very good for us because now P2 is available for us for this agent. So what should agent A1 do? What should its F post be? If it puts its F post as P2, then if A1 modifies its preference list having P2, then it's very happy, but it would also not. So let's see, first of all, this ensures that it can get matched to P2, but then what should its S post be? Because if it leaves everything like this, then there is also L of A which will come into picture. So at some points it will get P2, some points it will get unmatched, which may be even worse for him than just always getting matched to PT minus 1, right? So is there a nice post that it can make it as its S post so that it never gets assigned to that? Yeah, what is that post? Yeah, what kind of post is that post? F or S? In fact, if it is an F post, it will not become your S post, right? So it better be a S post inside the cycle component or which can reach a cycle component. So if you choose this as, so let's call these posts something P6, P7, P8, then if it selects P7 or whatever is this post P9 as its S post, then if it selects P2 and P9 as its modified preference list, then it will apply this switch, get another matching in which everybody gets matched to its F or S, A1 gets matched to P2 and A1 has its S post as P9, but that post is never something that he can get, right? So therefore, so this is one way he can falsify. The other way is that if you have a P2 which is in your own cycle component, but so if you had your P2 or anything which is in your own cycle component but which has a directed path, so this is P2, P3, so this is S, this is an F. So if the picture looked like this, yeah, I'm very sorry. Yeah, I think the red posts are correct. So if your P2, instead of having this as the picture, if this was your picture, it is in the same cycle component, but it has a directed path to PT, then you can apply the same trick, that is you can first unmatch PT, because anyway you don't want that applicant to get matched to PT, so you can remove that applicant to be matched to PT. PT then becomes free, and then you can start at P2, apply this path. Everybody along this path just switches along F to S and vice versa, and then you make P2 as your F post because P2 has become free, you get assigned to it, and there's finally again the P9 or whichever post which is in the cycle component which is an S post, which you make it as your second choice. So yeah, I think I'm rushing through this, but I will write down the exact strategy. I'll take 5 more minutes. I will write down the exact strategy, and hopefully it is clear, and some more work in the tutorial will help you clarify things that I have left. So an AS agent is somebody that M of, so this is an agent A1 such that M of A1 is equal to S of A1, which is equal to PT, and this belongs, this is just the description of this agent, to a cycle component and PT is not contained in a cycle. This is how this applicant is characterized. So the strategy for that applicant is for every, yeah, and I don't think you should write it because it's there in the write-up. For every ith ranked post, Pi of A1 where I is equal to 2 to T minus 1, check if I should not write 1. Pi belongs to tree component or non-sync component, sync component of GM, or Pi has a directed path in GM to PT is equal to M of A1. That is the matched partner of A1. If no post satisfies this property, then true preferences are optimal. A true preference list is optimal. Else, FH of A1 is equal to Pi, where it is the most preferred because we have gone in that order, and SH of A1 is equal to SG of A2, where M of A2 is equal to P1. This is a clear way of saying it, that is, you select that applicant who is assigned in that popular matching to your first rank post, ask what is its S of A, because you are in that cycle component, that applicant is also in the cycle component, his S of A is also something that can be reached via the cycle, and therefore selecting that as your S of A will always ensure that you will never get assigned to that S of A. And this preference list is actually the falsified preference list, that is, you just give a 2-len preference list, FH of A1 is Pi and SH of A1 is the same as SG of A2, where M of A2 is P1. And I should just say that preference list of A1 is P1, P2 up to PT, where this is F of A1, FG, and this is FG of SG of A1. Yeah, so so I have not proved that if this is not possible, then if this post is there is no post satisfying, then there is no such thing, but that holds, and the proof is there in the write-up, so I don't have the time to cover that. We can discuss some of it in the coffee break. So I like to just summarize that what this tells us is that again these popular matchings also are not prone to, I mean, they are not, we can cheat when when the central authority does choose a popular matching, but for this you should observe that we required lot of information, that is, we required to know true preferences of everybody. In particular, in general you may have only some high level information or some probability distribution over the posts, over the preferences of other applicants, and one would like to ask what can one do under such realistic scenarios. And to summarize, we have looked at two important things. One is stability and another is popularity, which in the two-sided preference list model can be thought of as a relaxation of stability. Popularity in the one-sided preference list model is completely different in terms of whether it exists or not, and it has some interesting connections to other things including voting and so on, which will hopefully come out as the school progresses. So, at this moment I would like to thank you for your participation, and I hope you have an enjoyable school ahead. So, all the best. Please make most of this school that is there for you. Thank you very much.